All right, today we're going to finish section 7.4 about percent. We're going to take a look at example number 6 and talk about using mental math to solve some percent problems. One of the things that I would like to remind you of, although I've said it before, mental math is something that you could reasonably do in your head. Okay, it's believable that you did it in your head, right? But you have to show me what you did on paper so that I know what you were thinking when you did it. So this is a really good example of those kinds of problems because every time I ask these on a test, I will have students who will either not show me enough work for me to know how they did it, or they'll do something that they'll sometimes even write it down, where it takes like 5 or 6 steps, and I'm like, I don't really think you could do that in your head because I probably couldn't. Okay, so there's a limited number of things you can sort of hold on to at the same time reasonably in your head, and keep in mind that your students that you're actually working with on material like this can hold in less than you. So when we're looking at mental math, we want to think about something that we can do in 2 or 3 steps maximum for it to really be considered mental math. All right, so the first one is asking you to do something with 15%. So one of the key ideas with percentages is to break them down into things that we can do easily in our head. For example, 15% is very nicely 10% and 5%, right? Yeah. So if I wanted to do 10% of 42, what would it be? Right. It's very nice because I simply move a decimal place. It's 4.2. Well, once I know 10%, it's nice and easy to find 5%. How would I do it? Yeah. Then I just need half of 10%. So I'd need 2.1. And then I'd add those together. That would be 6.3. Now, it's quick and dirty in written form, but it was precisely 3 steps. One was moving a decimal place, remembering that that's 4.2. The second one was dividing it by 2, remembering you had 2.1 or recognizing you had 2.1. And the third step was adding them together. That's sort of about the limit. Anything that would take you more than that, there's got to be a different way of doing it that would be quicker, simpler, easier to do. Okay, 3 or fewer steps is your key. So, on part B, 20%, what might you actually do? 10% times 2, right? So let's find 10%. So what would 10% of 280 be? Oh, one more thing. These are dollar amounts, right? Yeah, so we need to put a dollar sign in front of my $66.30. And if it bothers you, write the 0 after it. I don't care, okay? Okay, so a 10% of 280, you guys said just a minute ago, was 28. And then multiply it by 2 or double it. So what is 28 doubled? It's not quite as pretty as the addition on the last one. It's 52. It might be easier to think, not 52, I said the wrong thing, 56, thank you. I misheard. It might be easier to think of what is 30 times 2, 60, and then take away 2 twice, because that's close. It's 56, okay? That's actually only 2 steps on this one, the 10% step and then the doubling it step. So that's good stuff. Let's do C. 5%. Well, we've already seen how 5% sort of works. What would be the idea to get 5% all by itself? Right, 10% of, in this case it's 32, and then we will half it, just like we did the doubling it. So what's 10% of 32? 3.2. So again, that's not as nice to half as the last one was, but we can still manage, I think. What's half of 3.2? 1.6, or $1.60 if you want to put it with 2 decimals for money. 1.6. Okay, so D is the one where people, whenever I've asked this particular type of question on a test, they want to make it really hard, okay? So they want to do it something like this. They say 25%. Oh, that's kind of like my 10%, and it can be. The problem is that if I do this, then I've got to get 10% and double it, and I have to do 10% and half it, and then I have to add those values together, and all of a sudden you've turned something into far more steps. Okay? So dealing with 25% is actually easier to think of in fraction form. So 25% is 1/4, right? Okay, so we would actually be asking ourselves equivalently, what is 1/4 of 84? Or you can say, what is 84 divided by 4? It's the same question. And it does work out nicely, especially on this one. What is 84 divided by 4? It's 21. That's 1/4. All right. Any questions on the mental math ones? Okay, so they don't have to all be done the same way, although it's very nice to build upon the idea of 10% when you can, just because they're so friendly. All right, question number 7 says, why is it possible to have an increase of 150% in price, but not a decrease of 150% in price? Okay, so you're actually answering the second part of the question, Brooke, and you're exactly right. If I were to try to decrease something by 150%, I would end up with something negative, right? If you decrease it by 100%, what do you end up with? 0. You got nothing, right? So if I decreased, so if you go to the store and they say 100% discount, man, stock up. But they're not going to say 150% because then they would get to the register and they'd have to pay you money to leave with their product. It's not going to happen, right? Yeah, so that's a good point. So let's actually mention that first. It's the second part of the question, but it's the easier one to sort of maybe think through, is a decrease of 150% would yield a negative value. I.e., they would never pay you, that's what a negative value would mean, to take their product. If they do, you should start questioning what's in that product. Seriously, right? Okay. So why can you have a 150% increase in price then? Yeah, so if we had a 100% increase, or let me go back to the decrease for a second. If we had a 100% decrease in price, it'd make it 0. But if we had a 100% increase in price, it would double it, right? So this would be just more than double the price of the product. This is what stores do all the time. Otherwise, they don't make a profit, right? Walmart does not stay open because you walk in and you pay the same thing for their product that they paid the person they bought it from, right? It doesn't work like that. So, whoops, there we go. An increase of, and I'm just going to use that same one that you kind of mentioned being double, so 100% in price would be doubling the price. So a 150% increase would be more than that. You could almost say the reason that you can do the increase is because you're adding. The reason you can't do the decrease of that big is because you're subtracting. I can only subtract so much before I'm down to negative numbers, but I can add all day long, and it will work out mathematically to being something that's plausible. Now, maybe somebody won't buy it at your price, but you could market that way, right? Good. Okay, the last part of this section talks about interest. So we're going to look at a very specific type of interest application, and it's just simple interest. So this section, before they revamped the book, used to include compound interest, and it doesn't anymore. So we're only going to be looking at simple interest. Interest is simply the amount of money that you pay or earn to borrow or lend money. So if you've got a car loan, interest is the amount of money that you are paying monthly or biweekly or whatever it is for the luxury of having borrowed the bank's money to have that car. Or if you have a savings account, the amount of money they put in at the end of every month or every quarter, that's the money that you have actually earned because you let the bank borrow your money, because that's really what a savings account is. It's the bank borrowing your money. Notice you get much smaller interest rates than they charge you for borrowing it the other direction. But again, it has to work that way, or otherwise it's not going to actually be operational for the bank or the credit union or whatever you're using. Principal is the original amount that it's used to determine interest. So principal is either the amount of money that you put into the account or that is already there, right? Like maybe it's a savings account that you're not really adding to, it just sits there. That's the principal then. Or it's the amount of money that you borrow for that loan that you're taking out. Okay, that's principal. The interest rate is the percent used to determine interest. And then there's two forms of interest equations for simple interest. A equals P plus PRT, or A equals P times 1 plus RT. These are really not different equations. This is just P distributed. You guys see that? It's not a different equation. It's just presented in two different ways. Sometimes it's nicer to think about like this, because this right here is the principal, and this right here is the interest. Principal, what you actually borrowed, plus the interest, how much money you have to pay back, in addition, is the total amount that that car or your education or the house ends up costing you over time. So that's what this is saying down here. This I equals PRT is the interest part in the equation for determining your total value for your ending result of your simple interest equation. Okay, so we're going to do an example. Example 8. A company is expanding its line to include more products. To do so, it borrows $320,000 at 13.5% annual simple interest for a period of 18 months. Oh, I didn't mention this to the side. I'm sorry. Let me go back real quick. The rate R is as a real number, not as a percent. So you have to turn it into a number form or a decimal form. I'll write decimal here as a reminder. And T is always in time, in years. Okay, so if they give you something in months like they are in our problem number 8, we have to turn it into years or it doesn't make sense. Okay, so if I put in 18, I would be saying 18 years. My problem actually says 18 months. All right, so how much interest will the company be charged? Well, if you want to do just interest, you can just do I equals PRT. Okay? So P is the principal. What is the principal in this equation or in this context? Yeah, it's the amount of money that borrowed, $320,000. R is your interest rate, but we need to turn the interest rate. I realize 13.5 is a decimal, but we need to turn it out of a percent form into its decimal component form, which means moving the decimal 2 to the left. So this as a number is 0.135. So my R value down here is 0.135. And the time says 18 months, but I need it to be represented in a yearly value, so it would be 1.5 years. Exactly. Probably really important at this point to have a calculator, because I don't think you want to multiply that out by hand. So if you want to grab a calculator out, these are kind of messy numbers, because they're real life numbers. 320,000 times 0.135 times 1.5. $64,800. Do we agree? Yeah. So they're paying almost $65,000 to whoever they borrowed their money from in order to borrow that amount of money for that amount of time. That's what you just found out. It's a lot of money. A lot of money. All right, we're going to take a look at kind of an interesting question. Not too long ago, the housing market, I say not too long ago, probably longer ago than what you guys would ever remember, took a huge dive, and it was that way for quite some time. Fortunately, it was right when we were moving to Oklahoma, and we got caught in the middle of it. And that's probably only a couple years after when I created the question. So obviously what was on my mind at the time. So here's a interesting situation. Because of a recession, the value of a new house depreciated, means went down, 10% each year for 3 years in a row. Then, for the next 3 years, the economy began to recover and the value of the house increased by 10% per year. It's very tempting to say you're back where you started. You went down 10% 3 times, you go up 10% 3 times. Are we back where we started? That's the question for part A. Did the value of the house increase or decrease after the 6 years? So, the cool thing about this problem is that you get to make up the cost of the house. It won't make any difference what you pick. Your results are going to be the same in the end when we finish this problem. So I'm going to suggest we use a nice number like $100,000 because it's reasonable. You could have a $100,000 house. That's how much my first house cost, $100,000. But it's also a nice number with lots of zeros. I like zeros. So we're going to say that the initial cost of our house is $100,000. Okay? Excuse me. And then what we're going to do is that we're going to make it go down for 3 years. So, if it goes down 10%, then it's worth 90% of what it was the year before. Shake your head if that makes sense. 90 plus 10 is 100, so that's where I'm getting the 90. It's 90%. So, after year 1, I would have my $100,000 house, and it's worth 90%, so that's times 0.9. It's a percentage of what it used to be, and you probably could have done that one in your head without me even saying 9% like the way I did it, and that's okay. But what would I have for the cost of my house after year 1, or the value of my house? What's 100,000 times 0.9? Nobody wants to talk to me. Thank you, 90,000. So $90,000 now. So, how about after year 2? Well, we don't just take off 10,000 more. I mean, like that's what happened here. We need to take our value of our house, which is now 90,000, and we need to multiply again by 0.9. Okay? Because it's worth 90% of what it was the year before. So what is 90,000 times 0.9? 81,000. So we didn't lose $10,000 this year. We only lost 9,000. Year 3. Now we have an $81,000 piece of property. It goes down another 10%. How much is it worth now? $72,900. Very good. Almost $30,000 less, but it's not $30,000, right? It's not $10,000 every year. Okay, so that's the 3 years of the recession. It's going down 10%. So if I multiplied by 0.9 on the way down, what do you think I might multiply to compensate as I'm moving up and it's supposed to be increasing 10% per year? Any thoughts? Yeah, you could. And there's a faster way of doing that, Brooke. You could multiply by 110%. Yeah. So 10% more plus the original 100% would make 110%. And if I wrote this down as a decimal, that would be 1.1. Just like my 90% is the decimal 0.9. Okay? So I'm going to take my current value of my home. It's not supposed to say year 3. It's supposed to say year 4. Which was $72,900. And we're going to multiply it by 1.1. Or you could do 1.10 if you wish. What do we get if I multiply 72,900 times 1.1? Good. 80,190. So year 5 looks much the same. But now I have 80,190. times 1.1. What will that give me? 209, okay. And then my last year of discussion here is year 6. I have my 88,209 times the 1.1. And what will I have? 97,029. Okay, so we're going to round to the nearest whole value just because we're talking big money on houses, so we'll just go with $30 at the end. Okay, so the original value of the home that I made up was $100,000, and the resulting value after 6 years is $97,000. Did the house increase or decrease in value over the 6 years? It decreased. And there's absolutely nothing special about me starting with $100,000. No matter what you start with, the ending result will be a decrease from the original value. Now, the next question is a little more interesting because it actually asks you by what percentage did it increase or decrease over the 6-year period. So one of the things that you learned about in the first part of this lesson, the video that I recorded and sent for you for last time, is that you can always write something in a percent form as part of it's over 100, right? Okay, and I'm looking for that percent value that's on top. So this is the piece I'm looking for. And it says, by what percent did it increase or decrease over the 6 years? Well, we know it decreased. It was 100,000, now it's 97,000 and some change. The original value was 100,000 that we made up. So the numerator here is the decrease. It's the 100,000 minus that 97,030 that we ended in. That's how much it decreased, right? I mean, more or less it decreased by $3,000. That's what that looks like, approximately, but not quite. So if you take that and you divide, and then you you subtract, and then you cross multiply, you're going to end up with 100,000 equals 297,010. That's all right. Yeah, 297,010. That's what I've written down. And then if we divide by the 100,000, then we find out that it was a 2.97% decrease in price. And here's the cool thing. If you had chosen a $250,000 house or you had chosen a $40,000 house, this percentage at the end will be exactly the same no matter what. Because all of your calculations were percentages based on the original value you chose. So you will still get 2.97% as a decrease at the end. Any questions on that? Brooke?
How did we get the 010?
I just subtracted. So if you subtract these two, 100,000 minus 97,030. I didn't do it in real form. I just wrote it down for my notes. So I assume it's right, but. What I might have done is used the longer version of it that we'd had before. So we did times 100. Yeah, it's 0 on this one. We'll go with that since that matches better. You're still going to have the 2.97%. Okay. You ready for some current events data? Kind of excited. I've been keeping track of data since April 1st. Right up until I just posted the new data on Facebook right before I came to class, right after Lydia left me. Yeah, that's what I did. That's what I was doing. COVID data. As of August 1st, 2020, the total number of positive cases of COVID-19 in the state of Oklahoma stood at 37,731. Okay, so you guys could go look this up. I'm not lying to you. This is the number. I've been keeping track. The population of the state of Oklahoma as of July 1st, because I couldn't find it as of August 1st when I was looking at this, so you're just going to have to be okay with it being pretty close to okay, all right, was 3,956,971. So many people were in Oklahoma. Part A asks, what percentage of Oklahomans had contracted COVID-19 as of August 1st? So, it's a percentage problem. Okay, this is a percentage problem. So we can set it up just like we were doing our other percentage problems. Over 100, and we have X. All right, so what's going to go on top and what's going to go on bottom? The 3 million goes on bottom, so 3,956,971. What's your numerator going to be? That's the 37,000 number, right? 37,731. All right, so we're going to cross multiply. And then you'll divide by the other piece that's there. I don't have my in-between steps. I just have my final answer written down. So what'd you guys get? Anyone?
So it would be that. Oh, I haven't finished it out yet.
Maybe I should write it down. Do you have it, Lydia?
I just had a question.
Yep.
Why did you put X over 100?
This is the percentage. So this is always taking something and making it out of 100%. So this is the percentage that we have. This isn't the only way to do it, but this was the way that the lesson was presented prior to me doing this. And then this right here is our 100% of our people. So the total number of people on bottom and the percentage that applies on top. Close. I believe that you should have gotten 0.95%. So did you know that 0.95% is not the same as 9.5 and it's not the same as 95? And people confuse that all the time. I've told you about my Sonic experience when I go by the Harrison Sonic, right? And they tell me that their Route 44 is 0.99 cents. 0.99 cents would make it less than a penny. Yes. $0.99 is what they really mean, right? This is almost 1%. That's what that number is. 1%. Not 10%, not 100%, but 1%. Okay, let's go a little further. Y'all are going to be teachers, which is why I created the problem like I did. 10.92% of the positive COVID-19 cases are in kids ages 0 to 17. Again, I know that's not ideal. High school goes all the way up to 18. Y'all are not going to be teaching the kids at the higher end versus the younger end, but sometimes you just go with the data you can find. This is what I got. Okay? So if 10.92% of the cases are in those kids, this question wants to know how many kids does that 37,000 reflect? How many of those actually had it? So, kind of like what we did before with our 100%, the difference is that now we actually know that the 10.92% is the percentage. And we also know that the total number of cases, positive cases from the previous part of the problem, was the 37,731. What we don't know is that the number of kids that this actually represents. Okay? So, I'm going to multiply, cross multiply all that stuff again. I actually have this one written down. 100x, I have 412,022.52. I know we can't have 0.52 of kids, but just bear with me for a minute. I promise we'll turn them into real kids in a minute. This is just pretend kids for the purposes of math for the moment. Okay, so what would be my last step to doing this then? Yeah, divide by 100. So we'll divide by 100. And if I divide by 100, I end up with, rounding to a whole number of kids anyway, 4,120 kids. So it's not true that kids don't get it, right? 4,000 of them as of August 1st, approximately, give or take a little bit with my percentages being a little wiggly, had COVID at that point. Okay, ages 0 to 17. All right, one more piece of data. I looked all this stuff up. Creating your problem was actually kind of fun. All right, there are 900, as of July 1st, 981,328 kids who are between 0 and 17. 981,000. Using for your answer from Part B, what percentage of children in Oklahoma had tested positive for COVID by August 1st? Okay, so it was 1% of the total population, right? That's what we found out from Part A in Oklahoma. And so we're going to find out what our 4,120 kids is out of the total population of kids. So we have 981,328. And that's some percentage over 100. So I have my 981,328 x equals 4120 with a couple more zeros, and divide. What percent did you get?
4.2.
If you round up, 0.42%. And this isn't a part of this lesson, but I'm actually going to give you a reference point. It can be really confusing. It's easier for us to look at the 0.95%, say it's almost 1%. And we could say 0.42 is almost 0.5%. I mean, we can do that. But when we talk about decimal points of percents, that really confuses. It really does. And in fact, the general population probably moves the decimal over and thinks of this as 4.2, which it isn't. So you could actually, in another way of stating this, say the following. This is 4 out of every 1,000. That's what that actually means in a sort of contextual sense, 4 out of every 1,000. That does not mean 4 out of every 1,000 has it at any given moment. It means has had it since April 1st, or since the beginning of, say the beginning of time, beginning of tracking, I guess, anyway, I don't know. So that's actually what that number looks like. So everything that's going on in the state of Oklahoma with education and the decisions they're making are based on this statistic in theory. And I'll let you decide whether or not that makes sense to you.